Welcome. I'm going to do an example of the Unit 6 project on predicting the future with exponential functions. Okay, so the first thing you need to do is read the instructions. Basically, what you're going to turn in is a graph, an equation, and an answer to the word problem. And then a brief reflection on what you know about exponential functions. Choose your word problem. The middle three, so the first and last are kind of hard. The one's about population because they've got really big numbers, but the middle three are a little more doable. So choose one of these middle three. And there are examples right there in Desmos. So there's the example I'm going to do today, that the notes for it are right there in Desmos. And this screen, I know it's kind of hard to read, but if you just like zoom in on it, you'll be able to see parts of that graph and table and stuff a little better. So the word problem I'm going to do is this one. In 2020, Kasara bought a condo for $415,000. The value of her home grows exponentially. And by 2021, the house is worth $430,770. So I have to write an equation to model the value of Kasara's home. And assuming the current growth rate creeps up, I have to predict how much it's going to be in 2050, which is 30 years in the future. So I'm going to basically recreate this table, but I'm going to do it on the next page. And I'm going to use these numbers, just like you'll use certain numbers from yours to do it. So there's the starting price, $415,000. That was in 2020. 2020 is going to be my year zero. That's where I put this $415,000 in there. And then 2021, by 2021, it was $430,770. So I'm taking those numbers and I'm putting them into the table on the next page. So year zero, again, this was 2020. And she bought her house for $415,000. So the number I'm writing in here is $415,000. And then by 2021, just calling year 2020 year zero and this year one. And that'll make my math easier later on, actually. Let me just double check how much it was worth in 2021 was $437.70. This is the year since 2020. And this is the value of the home. So now I'm thinking, okay, well, how can I figure out the rate and the start value? The start value is just whatever number is next to the zero. Okay, so the start value is 415,000. And that's one thing I'm going to need for my equation. My equation is y equals start value times rate to the x power. My rate is going to be the second number divided by the first number. So my rate, and the reason I'm dividing instead of subtracting is because this is exponential growth. And exponential growth multiplies each time instead of adding each time. So in order to figure out what it's multiplied by, I'm going to divide. So I'm doing 430,770 divided by 415,000, and I got 1.038. So now I'm going to type in my equation. Start value is 415,000. My rate was 1.038. It's raised to the x power. If you look at the 6 key, so in order to type an exponent in Desmos, if you look at the 6 key on your screen, you'll see a little caret that looks like this. And you're going to use that to type the exponent. Okay, so it's raised to the x power. Oh, there, it showed up right there in the equation. So that's my equation. I'm going to use that exact same equation on the next page to create my graph. I'm actually just going to copy it right over. Notice that my graph isn't showing up yet. So now what I'm going to do is I'm going to do a process of guessing and checking to find out where my graph is. And remember, I'm looking 30 years into the future. Year 0 on this graph, that's 2020. I want to find out what the house is worth in 2030. So since I'm looking 30 years into the future, I want my x-axis to go a little bit over 30. So I'm going to set it to 35. My y-axis, I know it's at least 415,000 because that was my start value. It's probably going to be something much bigger than that. So I'm going to change that, the maximum on that, to something even bigger. Okay, let's say 415,000. Maybe it's going to be worth $1 million. Let me try $1 million. One with 6 zeros after it. Okay, so now I'm going to take a look at my graph and see, does it show me 30 years? Here's 30 on the x. I still can't see where the graph crosses 30. So this line ends here, so it means I have to go even higher. Well, maybe I'll try 1,500,000. So I'm guessing and checking to get to that big enough number to see the graph. Okay, so here's 30, and now my line crosses the 30. And I can see from the graph that in 30 years, my house will be worth $1,199,059.57. Okay, well, let's remember that number because we're going to use it to check our answer on the next thing also. So now I'm going to solve the same problem which I just solved on the graph, but I'm going to solve it using the equation. And it's that original equation I wrote. Y equals 415,000 times 1.038 to the x power. Okay. 415,000 times 1.308 to the x power. The x in this means how many years in the future, right? So we're going to just plug in 30 for the exponent here. (1.038 to the 30th power). And now, if I actually use the calculator function on here, I can get Delta Math to help me with this. 415,000 times 1.038, and then it's raised to the 30th power. Maybe it was on this one that you can do that. Okay, so I can't do the trick where Delta Math helps out, but we're going to go ahead and just go to the Google calculator, type in that same equation, and it'll get us the answer, the final answer. $415,000. Let's raise the X power, so that's this button right here. And it's to the 30th power because we're looking 30 years in the future. I got $127,482.54, and that's my final answer. I'm going to keep it rounded to 2 decimal places because we're talking about money. Okay, so once you got all that, you're basically done with the calculating part of the project. You just go ahead and answer these few reflection questions, and that's all.